So welcome everyone to Managing Dependencies for Spring Projects with Gradle. I'm Jenn Strater, or as you may know me on Twitter, the Code Generator. I'm a developer advocate for Gradle, the company you may know from the Gradle build tool, which we're going to talk about today, and Gradle Enterprise. And today I have with me...
Hi everyone, my name's Andy Wilkinson. I work for Pivotal, where I primarily work on Spring Boot. I'm also the lead of the Spring RESTdocs project, and I wrote most of Spring Boot's Gradle plugin and the dependency management plugin that it uses that we're going to talk about today.
Yeah. So the way this is going to work is that Andy's going to do a little bit about the Spring Dependency Management Plugin. I'm going to talk about how the new features in Gradle incorporate a lot of the work that Andy's done. And then we're going to talk about how you can migrate from the Spring Dependency Management Plugin to some of the native Gradle stuff. So just to kind of see where we are, who is using the Spring Dependency Management Plugin now? Okay. Has anyone started using the Gradle 5 native BOM support? One. Okay. So this is definitely the right talk for everybody in here. So Andy, get started.
All right, thank you, Jen. So perhaps a little bit bizarrely for a talk about Gradle, this story really begins with Maven. So Spring Boot is a project that is built with Maven, and it relies on some fairly major Maven conventions. And those are conventions and functionality that we wanted to bring to Gradle users. For people who've made the decision to use Gradle rather than Maven as their build tool, we wanted to be able to bring some of Maven's advantages to the Gradle world. So, as probably a lot of you know, in fact I should ask, how many of you are Spring Boot users here? Pretty much everybody. And how many of you are already using Spring Boot with Gradle? Okay, a good chunk of you. Okay, so for those of you who are Spring Boot users, it's almost all of you, you may well know that there is a Spring Boot Dependencies module within Spring Boot that is a Maven bill of materials. Now, if you're using Spring Boot with Maven, you may be more familiar with using Spring Boot Starter Parent as your project's parent, and it actually inherits from Spring Boot dependencies. So even if you're not using Spring Boot dependencies directly, if you're using Spring Boot Starter Parent in a Maven world as your project's parent, then you are in fact still using the Spring Boot dependencies BOM. And what a bill of materials does is it manages dependency versions for you. It also manages Maven plugin versions, but that's of no relevance if you're a Gradle user. But that information is in there and does help you if you're using Maven. And the Spring Boot Dependencies BOM manages both Spring versions of Spring projects, Spring Boot itself, but also a large chunk of the rest of the Spring portfolio. So it manages dependencies for Spring Data, Spring Security, Spring Framework, Spring Session, etc., etc. And also, we manage third-party dependencies, so things like Hibernate, Flyway, various JDBC drivers, Cassandra, etc., etc. They're all managed in there, which gives you a curated set of versions so that hopefully when you're writing your app, you don't need to worry about versions quite so much. And in the BOM, we have over 150 properties. So these are the things that, there's a single property for Hibernate's version. And then those properties are used to control the version of 800 or so different dependencies. And it looks a bit like this. So this is a heavily reduced version, but you can see up at the top, an example of a couple of the version properties. So this, I believe, is a snippet from Spring Boot 2.1.4. So you can see that Spring Boot 2.1.4 gives you Spring Framework 5.1.6 and also gives you Timeleaf 3.0.10. And then you can see below an example of the dependency management. So here we're managing a particular Timeleaf dependency. So this is the core Timeleaf module of the Timeleaf project. And its version is controlled by that property. So we're basically saying Spring Boot's opinion is that if you're using the core module of Timeleaf, the version that you should use is 3.0.10. And that's the one that Spring Boot, this version of Spring Boot has been built with, and the version that we've run all of our tests against as well. So why is a BOM a good thing? Why is this something that we thought, that Maven users could use? Why did we want Gradle users to be able to use it as well? What does it do for you? Well, as I already mentioned, it removes the need to think about versions when declaring dependencies. You can just say, I want to use Spring Boot 2.1.4, for example, and you'll get a set of versions that we have run all of our tests against and we believe all work together. It also means that you get consistent versions across a library's modules. You'll sometimes see, if you've got a bunch of different dependencies and they have transitive dependencies on the same third-party project, you might end up with version 1.2.3, or as here, version 1.2 of a bit of it and version 1.1 of another bit of it. Sometimes you'll get away with that. If they're two different maintenance versions, you might just about get away with it. If they're different minor versions, or even worse, different major versions, you're very likely to run into, no such method errors, abstract method errors, that kind of thing, where there's an incompatibility, and you've got different mixed versions at runtime that were never designed to work together. Using the BOM will mean that we provide an opinion about the version of every single Hibernate module, every single Timeleaf module. So if you're using the BOM, either in Maven or in Gradle, we'll make sure that all of Hibernate's modules are all at the same version. So it should eliminate these kind of incompatibility problems from your build. Gives us default versions, as I've said, that are tested and known to work together. So these versions that you get in the BOM are the versions that Spring Boot's unit integration tests have all run against, so we have a reasonable degree of confidence that they all work together, which hopefully saves you a bit of time and effort when you're integrating things. But the other thing that's good about a BOM is it really is just an opinion, and if you disagree, then it's pretty straightforward for you to override that opinion. This could be because, say for example, there's a bug fix release of Hibernate comes out, and there hasn't been a bug fix release of Spring Boot to pick up that version of Hibernate. You can just say to Spring Boot's dependency management, I want to use Hibernate 5.3.12 rather than the 5.3.11 that you're giving me, for example. And using the properties, and we'll take a look at this in a little bit more detail later, using the properties declared in the BOM, you can just provide a different version for that property, and then all of the modules will be that version rather than the opinion from the BOM. So this all began back in July of 2014, so almost 5 years ago now. And when I was pulling this together for presentation, I couldn't quite believe that this was 5 years ago. To begin with the Gradle plugin, and I can't remember why we did this, and when I think back, it just feels completely daft. We used the properties file for managing all of the versions with Gradle rather than reading it from the BOM. We took the BOM from the source code, ran it through some horrendous XLT transformation, turned it into a properties file, and then we wrote a plugin to read the properties file rather than just reading the BOM. And I have no idea why we did that. I can't remember. It probably seemed like a good idea at the time. So about 5 years ago, we thought, actually, why don't we just use the BOM file? Why don't we just use Maven's well-known, well-specified, well-documented XML format and see if we can consume that in a Gradle build? So Phil logged this issue against the Spring Boot project, and that gave rise to this separate Gradle plugin. We did it as a separate plugin because we thought that it might have benefit to the community beyond Spring Boot. And that has proven to be true. We've had people raising the issues against the dependency management plugin who are building Android projects, something that's not even in the Spring community. So while this is a Spring Gradle plugin, if you have any non-Spring projects being built with Gradle, you can take advantage of the dependency management plugin functionality, and it doesn't depend on any of the rest of Spring. There's no need to build a project that's kind of tied to the Spring ecosystem with it. You can use it for whatever you like in a Gradle 4 project. In a Gradle 5 project, hopefully you'll use the stuff that Jen's going to talk to you about instead. So, if you want to use the plugin to import a BOM, it's fairly standard kind of Gradle stuff to begin with. You use the plugins block, you specify the ID of the plugin and the version that you want to use, and then the plugin provides a DSL to import Maven BOMs. It also provides a DSL that I won't go into details here, but you can also declare dependency management for individual dependencies. So if you don't have a BOM that manages the dependencies, but you say you have some a project that's internal within your enterprise, but you want to provide dependency management for it to make sure that you get this consistent set of versions that I talked about, you can also declare individual dependencies, manage individual dependencies using the plugin's DSL. And here we're just saying we want to import a Maven BOM, and it's the org Spring Framework boot Spring Boot dependencies, so it's the exact same Maven BOM version 2.14. And that will leave us with a Gradle project with the dependency management that's been imported from that BOM. And the dependency management plugin provides a new task for you, similar to how Gradle has its dependencies task that you can run, and it will show you a list of all of the dependencies that have been configured in your project. The dependency management plugin also provides a dependency management task. So if you run that, you will get output showing the details of all of the dependencies that are currently being managed. These aren't necessarily dependencies that your project is using. These are just ones that should you use the particular module that's managed, then the dependency management plugin will control the version of it for you. And you can see here a heavily kind of reduced output there. This is showing that we're managing some timeleaf modules. So we've got the timeleaf, core timeleaf module and the timeleaf Spring 5 module, both at version 3.0.11. And then we've got some timeleaf extras, which is managed as a separate project, has a separate release cycle. So those two have a separate version number. As those of you may know, your Spring Boot users, or maybe you didn't know, Spring Boot is already doing what I've just shown for you. So if you're using Spring Boot's Gradle plugin, so here using the plugins block, ID org Spring Framework Boot, we picked a particular version. If you apply the dependency management plugin, having also configured your Gradle build to use the Spring Boot plugin, it builds on Spring Boot's kind of auto configuration theme. By applying the dependency management plugin, the Spring Boot plugin takes that as a signal. You want to use the dependency management plugin to manage your project's dependencies. So that applying of the dependency management plugin, the Spring Boot plugin kind of turns that into an import of Spring Boot's dependencies BOM. So it means that you can just specify a particular version of Spring Boot and you'll automatically use the equivalent version, so the same version of the Spring Boot dependencies BOM to manage your project's dependencies. An important thing that I mentioned with the BOM support, and one of the benefits of it, is that the BOM is just an opinion and you can override it. If there's been, if you need to upgrade or downgrade for whatever reason, you can do that. And the properties in the BOM strive to make that as easy as possible, and that's something that's supported in the Gradle world. Actually, it's worth mentioning that in Maven, the property override support only works when you're using a BOM as a parent or as one of your ancestors, be it a parent or a grandparent or a great-grandparent. If you import the BOM, which is another way that Maven provides, and if you're how many of you here are Spring Cloud users? So you've got a few Spring Cloud users here. You've probably seen that you, in a Maven project, you import, typically you use Spring Boot Starter Parent as your parent, and then you import Spring Cloud's BOM, and it brings all of the dependency management together. The Spring Boot BOM, you can override properties because it's your parent, but the Spring Cloud one, you can't because it's imported, which is a shame. It's a limitation of Maven that I think there's an issue for it that they may want to address, but the last time I spoke to someone in the Maven community about it, they said it required a breaking change to the Maven model, so it will require a Maven maybe 4.0 perhaps, or Maven 5 perhaps, I don't know, because they're not having a 4.0 apparently. So you can do this kind of same overrides with the Gradle dependency management plugin, and you can use that, you can perform the override, irrespective of how you use the BOM. There's no concept of a parent in dependency management terms in Gradle. So when you use the dependency management plugin, you can import, when you import a BOM, you can override a version. And it looks a bit like this. So here we have a timeleaf Spring 5 dependency, and I haven't specified a version. So this is just kind of standard dependency management. By not specifying a version, you're saying, let the dependency management plugin dictate the version. So you can see here that the timeleaf Spring 5 module This little arrow indicates that we're going to use 3.0.11 release, and that version has come from the Dependency Management Plugin. You can also see where it's overridden some opinions. So Timeleaf by default depends on SLF4J 1725. The Dependency Management Plugin thinks you should be using 1726, so it's upgraded that dependency. So there you can see versions either side of the arrow. So that's where the transitive dependency did have a version on it, and the Dependency Management Plugin has said, no, I think you should be using this newer version because that's the one that's in the BOM. So you can override a version, and perhaps the most obvious way to do that is just to add the version to the dependency. So here I've said I'd like to use Timeleaf Spring 5 3.0.10. And if we look down the bottom, we can see that I have indeed got Timeleaf Spring 5 3.0.10, but I've also got Timeleaf's core module at 3.0.11 because the Dependency Management Plugin's opinion is that you should be using 3.0.11. So you've expressed an opinion about the Timeleaf Spring 5 module, and the Dependency Management Plugin has respected that, but you haven't said anything about the core Timeleaf module, so the Dependency Management Plugin has kind of clobbered that, so you've now got a mix of 3.0.10 and 3.0.11 in your project. You could add an explicit dependency declaration on the Timeleaf module and express an opinion there, but a better way to do it using the Dependency Management Plugin is to override the version instead. So this is the version that I showed you in the original BOM. So this is Gradle syntax for configuring an extra property. So here we're setting the timeleaf.version extra property to version 3.0.10, and you can see now that that's what we've got of both modules. So the versionless dependency declaration for Timeleaf Spring 5 has been upgraded or has been set at 3.0.10, and the Timeleaf module upon which it depends is also at 3.0.10. So you avoid this mismatch of versions by overriding the property rather than by specifying the version on an individual dependency declaration. The last thing that I want to talk about in setting the scenes of kind of where we are today, before Jenn talks to you about the more interesting stuff that is new in Gradle 5 and the stuff that's coming, is just a final feature that the Dependency Management Plugin has, is that it brings Maven-style dependency exclusions to Gradle. And this is probably best illustrated with a hopefully fairly simple example. So here I have some Maven configuration. So I have an exclusions module. And this example exclusions module has a couple of dependencies, has a single dependency. It depends on Spring Core 4.1.3, but we're excluding commons logging because we want to use, say, SLF4J instead, and SLF4J's commons logging, SLF4J over JCL stuff instead of using the commons logging API directly. So if we then depend on that project in Maven and in Gradle, and also pull in Spring Beans, so we're writing a Spring app, so our exclusions example module depended on Spring Core, but in our app we also need to use Spring Beans. So we've got the Maven configuration in the top left and the equivalent Gradle configuration bottom right. If using standard Maven and standard Gradle, we look at those dependencies, look at the dependency graphs we end up with. So at the top, we've got the output of Maven dependency tree, and at the bottom, we've got the output of Gradle's dependencies task. You'll see in the Maven example, we don't have commons logging, but in the Gradle example, we do. I think you could make an argument for either one of them being right. We don't really care. What we really cared about was that you got the same answer, not which one you might consider to be right or wrong. And Gradle is far more flexible than Maven. It was, whilst not easy, it was possible to change Gradle's exclusions behavior, whereas I don't think it would have been possible to do the same for Maven. And we care in Spring Boot because we have, as I'm sure almost all of you already know, we have a bunch of starter modules. And in those starter modules, we provide dependencies for you. And in some of those, we have exclusions because there are sometimes third-party projects that have dependencies that are declared as mandatory when in fact they're not. And in the way that we expect a typical Spring Boot user to use a dependency, that transitive dependency isn't needed, so we exclude it for you. Commons logging is the canonical example. Projects often pull in Commons logging, and then it gets in the way. If you're trying to route your Commons logging stuff into, say, SLF4J and then on into logback, you need to keep Commons logging off your class path. And our starters really try to do that. We have the Maven Enforcer plugin configured to make sure that it doesn't sneak in. So we're pretty confident for Maven users that you're not going to end up with Commons logging on the class path. We wanted to be able to provide the same degree of confidence for Gradle users, which is why we added the exclusion support to the Dependency Management Plugin to make things behave the same way. A downside of that is that it does slow your build down because there is more work to do. It has to go off and look at all the POM files, figure out what the exclusion should be, and then has to kind of mimic Maven's exclusion algorithm to figure out what to keep and what to get rid of, and then tell Gradle, right, these dependencies shouldn't actually be there. It's been optimized as much as we can, but there's only so much that can be done as a third-party plugin rather than natively in Gradle itself. So that really sets the scene, I think, with where we are today and why we got to where we are. I'd now like to hand you over to Jenn to talk to you about all the good stuff that's in Gradle 5 and is coming, and that you'll hopefully look at and think, and I say this as the author of the Dependency Management Plugin, so that you choose never to use it again. I don't want to have to maintain that code, so the more of you that use Gradle 5's dependency management stuff and give feedback to the Gradle team about what's missing and what you'd like to see, the better. Because something that's native to Gradle is used by all Gradle users rather than just largely a Spring Boot-centric community, I think is good for everybody. So with that, I'll hand you over to Jenn to learn all about it.
Thank you. So yeah, a lot of these features ended up getting included in Gradle 5 and even some of the more recent versions. And it's a really great story that we can tell here today because the Spring Dependency Management Plugin is actually one of the most commonly used Gradle plugins like of all time. And so those features are important to lots of people. And as Gradle has evolved, we want to incorporate those important features into the next and upcoming versions. And so we do that through consuming BOMs, through some better fine-grained access to, fine-grained dependency management, as well as some improvements that have come to actually publishing BOMs and incorporating that back into other Maven projects. So the long-term goal here is to be able to mix and match so you can have some projects using Gradle, some projects using Maven, and consume from Maven projects and then publish back to them as well. And so let's get started with kind of how native BOM support looks. Syntactically, it is a little bit different. And since the long-term goal is to make this more compatible not only with Maven, but with other what we're going to call platforms as well, the syntax here isn't just to like import a BOM, it's to do a platform. And so the platform includes Maven BOMs, but also things like the new Gradle Dependency Management metadata format, and in the future could apply to lots of other things as well. And so the example that comes to mind for me is a talk that I give about Spring RESTdocs. And in that example demo project, I often override the version of Groovy. And I today have it just as 257, so it's just a point release that I'm trying to override, but it actually came to my attention a while back when we switched from Groovy 254 to 24 to 25 because the version of Spock or testing framework wasn't compatible, so we were getting these, or I was getting these error messages about not being able to compile. And so what ends up happening if I try to use this as an enforced platform, which is the most similar behavior to the way that the Dependency Management Plugin works and that Maven works in general, is that I end up, even though I had specified that I want the 257 version of Groovy, I end up getting this 256 version because that is enforced. And so who has seen a Gradle build scan like this? Is this new to everyone? A few people. Okay, so this is a different dependency report than the one that Andy showed, and this is free if you do --scan at the end of any Gradle build that's 4.6 or higher. And I would end up going through and trying to debug issues like this by clicking any of those blue links, and it'll pop out and say kind of where that came from. So you can see that some of these are coming from the Spring Boot dependencies or from other dependencies that I had used in my project. But the very similar thing that happened here is that I just overrode the one particular version. What didn't happen is that I didn't get any of the other versions too. So what you can do is you can try and force that one particular version of Groovy. So you can do this by using force equals true, which is a bit heavy-handed, but you could also write a dependency management rule, which I'll show a little bit later, or a few different other things to try and override that. And so what happens now, actually let's try and guess. So who thinks that this is going to stay with Groovy 256? And who thinks it's going to do 257? Lots of people are not voting. Okay, so it does actually work in this case because we are then forcing that version back to 257. But you're going to want to be very careful in doing this, because if you start forcing everything, you're going to end up with the same conflicts, just at a different level. And so we can start getting a little bit more fine-grained here. And even this particular version only does Groovy. It's not advancing. Okay, so all of the other dependencies that are related to Groovy are not. So it's not doing everything in the group, just the Groovy version, which is what we had talked about there. So in order to do that, we have a couple other tactics as well. The first one being that we can delegate that to Gradle's conflict resolution instead. So by switching this from what I had before, which is the enforce platform. So enforce platform means that I want to take all of those as requirements, and by removing that and going to platform, we make those into recommendations, which Gradle's dependency management engine can then decide which version to use. So if I do it this way, it ends up with the same result, but with fewer forces. So it is finding the 257 version of Groovy. We get the same issue where it's only that one library, but it's using Gradle instead, so you could end up with fewer conflicts in the long run. Okay, so the next kind of progression here is to actually override all of the things in that group. And so this is is a dependency management rule. So we get a little bit more code here. It is not as easy anymore as just doing a little one-line force, but you get a lot more control over exactly what you want to do. In this case, we're going to configure a resolution strategy for everything in the Groovy group. You can, of course, even make this even more fine-grained and make pattern matching to do exactly which dependencies you'd like here, and get to this particular version. And then you can even add notes, because what inevitably happens with when you're trying to upgrade or even downgrade versions is that you want to remember why. Maybe there's a particular issue that happened in a later version, so you want to lock at a lower version of a dependency. And so we can both override that version and annotate why we were doing that. And of course, these are going to expand out the more dependencies that you're doing like this. So of course, doing it this way will work a little bit. And yeah, so that's kind of a few different ways. There are a lot more in the documentation as well. If you haven't had a chance to take a look at the new dependency management section of the Gradle docs, you should. There's a lot more included than just a few simple examples here. And even though the syntax is not as easy to go through, as Andy mentioned, there is a big performance difference here. So for this Spring REST docs example that I've been using, this is what came out of that dependency report. And so you can't even read it, but let's zoom in here. So what happens is that there are 90 different configurations that got spun off here. And this is a simple demo project, but like Andy mentioned, this is not this is the way that it had to be done, because in order to analyze the dependencies in the way that it was happening, like as a plugin author, that was the only way to do it. But because we can now use some internal APIs with Gradle and just the way that the team has constructed that, we can get it much smaller. In this case, it all fits on one page. I don't need to zoom in anymore. It's down to 12, and even within those, you'll notice a few things here. So I did include the links to all of the build scans in here, and the slides will be published at the end. If you want to take a look, you can click into those. Those are all public build scans that you can take a look through and see the differences between those dependency resolutions. But it's not just about consuming Maven BOMs as well, but also about how we publish and interact back with Maven from Gradle projects. And you may be wondering why to do this. If you're, of course, on a library author like someone on the Spring team, you publish things that way. But it's also useful for multi-module systems. If you're working with other teams and you want to publish your dependencies, you can do that. And so very similarly, the Maven Publish plugin has the Maven Publish plugin itself is not new. The thing that has changed in Gradle version 5.2 is that you now have the option to use your resolved dependencies versus declared dependencies. What that means is that we've been talking about all of these in some cases, the differences between the dependency management engines for Maven and Gradle. So if you want to make sure that the same dependencies that were resolved, not necessarily the ones that were declared, because you've got all of this version conflicts that you're having to rectify, you can use this syntax to use what was actually resolved and make sure that you're using the same in both the Gradle projects and Maven projects. And that then goes even further into this new plugin, which is to publish Java platforms. Right now, this is about publishing Maven BOMs from Gradle itself, and it might be a useful feature for some of you. And yeah, so we've already seen what a Maven BOM looks like. This is really just the Gradle DSL syntax for doing that. And so it's not just Maven BOMs, but eventually to get towards a new metadata format that Gradle has defined. And some kind of things that we notice as far as limitations in Maven and in and where we're heading with dependency management is to get into this new feature in 5.3 called feature variance. And so feature variance is, again, a very generic term to describe something that Maven is doing, but that we also want to apply to other build system, build system as well. So if you're familiar with the concept of Maven's optional dependencies, feature variance does that and more. And so the example that I want to use here is for databases. When you have a library that you're publishing that supports multiple types of database connections like MySQL, Postgres, and Mongo, for example, as a author, when you're publishing those, you want to be able to say that you can do either of those, but then you want to restrict, or maybe not necessarily want to restrict, but you recognize that there are conflicts if you try to use more than one of those at the same time. You can restrict that. So if I, as a consumer, and you were a library author that has published this, and I try to import two different versions, so in this case it's MySQL and Postgres, then it's going to give an error. And so this is kind of an important part of Gradle's strategy in general, that we want to fail fast. So rather than spending a lot of time trying to debug this later down the line, if we can know and recognize earlier that you know that there are conflicts between these two, you can restrict that and prevent problems from happening further down the line. And so that hopefully leads us into the Gradle module metadata format. And so this is kind of an example, it continues a lot further down that page obviously, of how we can take some of the things that we've learned from Maven and some of the things that we've learned from Gradle in the way that we define not only dependencies but other important metadata that are useful for publishing, and kind of redefine that a little bit. And so this is one of the important features that is coming in Gradle 6, and so this is why I named it 5 and beyond. So you can try it out right now. It's an optional feature that you need to enable in your Gradle build, but you can publish to both formats, and then starting in Gradle 6, this will be on by default. And so anytime you publish anything in the Maven format, you'll also get a copy of this Gradle module metadata format. Bit of a tongue twister. Okay, yeah. So that is a little bit of kind of where Gradle is heading and some of the things that you can do to convert from Dependency Management Plugin to the native support. And there are, of course, lots of other things that we mentioned in the documentation. You can run some build scans to kind of see how that differs in your own. And then there are a few kind of gotchas, perhaps, for migrating between these two. And maybe some things that we still have on the roadmap to fix. And so the first one is exclusions. And so exclusions are still much harder to define in Gradle, and so this is one of the things that's on the roadmap for the dependency management team to try and make a little bit easier. It is possible to define exclusions, but it ends up being a bit harder in the end. Another kind of little one is that you'll need to remember to add a different scope. So in particular, even projects as big as Micronaut, for example, weren't getting the right dependencies included. So you need to remember that the annotation processor needs to be separate. And so this is something that the plugin does, but that Gradle doesn't do for various reasons. So it's actually an intentional thing that we want you to think about which dependencies you actually want to use in each scope. Okay. And because some of this is new, so Gradle 5 came out in November of last year, so it's not entirely new yet, but some of these concepts aren't very simple. We've been talking about just like one small portion of how Gradle works in general, and even IDEs like IntelliJ haven't entirely caught up with some of these features. I usually run things on the command line, but if you are using the Gradle support that's kind of embedded in IntelliJ, as well as even the Eclipse versions, you may not see the same dependency reports. But this is something that we're working on. The issues have been filed. We've reached out to all of the IDE vendors to try and get this up to date. Okay, thank you. And so the last one that's probably the one that hasn't completely been fixed yet, that we still need to work on even a bit more, is more about overriding these version properties. So like Andy had mentioned, the way that plugin works is very special. It goes above and beyond both what Gradle and Maven were doing. And for upgrading versions, I showed you a few different ways that can happen, but there are still some problems if you want to downgrade your version. And particularly because Gradle by default wants to try and resolve those by going up, you have to kind of override force, and these are actually listed in order of what you should try to do. So you should try to write a rule first before you try to kind of heavy-handedly force everything. And then if you absolutely need to, exclude it and add a different dependency. But we are hopefully trying to fix a lot of these different issues, and I think you know a bit more about what the version properties are missing.
Yeah, I think it is mostly the override stuff, but as Jen said, The Gradle team have been really receptive to feedback. The dependency management team, Cedric primarily, who I've spoken with, has been very receptive to feedback, but doing things in the Gradle way. So they don't want to replicate Maven for good reasons. If you like Gradle, turning it back into Maven is not going to be a good solution for you. So if you have any feedback of your own based on trying out the stuff, then in my experience, it's well worth chatting with the Gradle team, particularly the folks on the Gradle team who work in the dependency management piece. I said, yeah, they're really receptive for feedback. So if you try out any of the stuff that Jen's talked about, then please do get in touch with them. And again, equally, if there's anything that you think the dependency management plugin could do differently, then please let me know as well. For those of you who are need to stay on Gradle 4 for whatever reason, or can't use the native stuff in Gradle 5 for whatever reason. But hopefully, longer term, the dependency management plugin can just kind of wither away, and the native stuff will take over.
Yeah, so that's a really great point. The best way to provide feedback is actually to go to our forum, so discuss.gradle.org, and kind of ask any questions that you have. The dependency management team is happy to help. We also have a dependency management series which goes into a lot more detail on a lot of the other concepts, particularly things that are kind of unique to Gradle itself. And they just published the first one on the Gradle blog, and we'll have at least, I think we're looking at least 2 more to go into even some more of this new metadata format information in particular, and how that differentiates from Maven BOMs. So right, as the conclusion here, we hope that everyone can switch, and if you can, you should, because you'll get a lot of the benefits, not only of performance, but also being able to more tightly control what happens. And yeah, I think that is most of what I had. And yeah, so the link to the Gradle.org docs as well. There's a really nice section on dependency management, particularly on managing transitive dependencies, which I've linked on most of those slides as well. The slides will go out via my Twitter account, so if you check there on CodeGenerator, it'll go out in a couple minutes once we've finished the slide, or finished the presentation. I know this is a lot. This is a really tough topic in building software in general.
All right. Thank you, everybody.